Hello, boys and girls. Today we're going to read the pages on light energy. Okay, the section is entitled How Light Behaves. The main idea of what we're going to be reading about is light travels in waves that can be reflected, transmitted, refracted, or absorbed by objects. So, at the end of reading this section, you should know what reflected light does, transmitted light, refracted light, and absorbed light. Okay, vocabulary words and pages you're going to find them on is the definition of light, reflection, refraction, and also what a prism is. Properties of light. And here's our first vocabulary word. Light is a form of energy you can see when it interacts with matter. Light travels in waves. Waves carry energy. You can make a wave by tying one end of a rope to a doorknob and shaking the other end up and down. The energy moves to the rope from your hand to the doorknob. The wave appears as a series of high points and low points in the rope. Okay, so as we read this next section, we're also going to be looking at the diagram of a wave. A high point of a wave is called a crest, and you can see here is a crest, and here is a crest. A low point is called a trough. Here is a trough, okay, there'd be a trough down here, and there'd be a trough down here. Halfway between a crest and a trough is the resting point. So, crest, trough, here's the resting point. Okay, trough, crest, here's the resting point. The wavelength is the distance between one crest or trough and the next. So this is a wavelength, okay, trough and trough, this would be a wavelength. So you're measuring between the points, okay, wavelength, wavelength. The amplitude is the distance between the resting point and a crest or trough. So the amplitude of a wave goes from the resting point to either the crest, or you could also have an amplitude from this resting point down to this trough. You could think of a wavelength as the length of a wave and amplitude as the height. Light waves travel in straight lines in all directions from a light source. I'm going to give you a little diagram of this. Okay, we have a light source, let's say the sun. Okay, they travel in straight lines in waves. So what that means is the waves are bumpy, but the direction they're traveling in are straight lines. A light source may be a bulb, a fire, or the sun. The light waves keep traveling until they strike an object. So, going back to our light waves again, okay, our light waves are going to keep traveling until they hit an object. So maybe the object they might hit would be a tree, okay. If the light waves cannot pass through an object, a shadow forms behind the object. So here, this tree, okay, is not transparent, it's not translucent, it's a solid object. So when the light hits the tree, it can't pass through it, and that's why we have a shadow of the tree on the ground. A shadow is an area that is dark because light does not reach it. Shadows form because an object blocks the light. You probably have seen waves in water. If you drop a pebble in the water, waves spread out in all directions. Waves of light spread out from a light source in a similar way. However, unlike waves of water, light waves do not need water or even air in order to travel. They can travel through empty space. For example, light from the sun travels millions of kilometers through space to reach Earth. Most objects that give off light also give off heat. Like light from the sun, heat travels from the sun through space in waves as radiant energy. Radiant energy is given off by other sources, such as heat lamps. When radiant energy strikes matter, it changes into thermal energy. Unlike radiant energy, though, thermal energy must travel through matter. Okay, so important to note that light waves can travel through non-matter, such as space. There's no matter in space. Thermal energy, okay, has to be traveling through matter. And we saw that when we looked at conduction, convection, okay, that they had to be part of matter. Okay, now we're going to look at what happens when light waves, okay, are not causing a shadow. Behavior of light. When light waves hit an object, the waves can behave in 4 different ways. They can be reflected, transmitted, refracted, or absorbed. How the light waves behave depends on the properties of the object. So they're saying that Whether it's going to be reflected, transmitted, refracted, or absorbed depends on the object that the waves hit. Reflection occurs when light waves bounce off a surface. When we see an object, we are actually seeing light that the object reflects. For example, you can see this page because it reflects some light into your eyes. Most surfaces reflect at least some of the light that hits them. Some surfaces, such as mirrors, reflect almost all the light that hits them. Surfaces that are very smooth reflect most of the light waves in the same pattern that light strikes those surfaces. This can make the surfaces look shiny. Surfaces that are rough reflect light waves in many different patterns. This makes surfaces look dull. So, for example, the carpet in our classroom, okay, it is not a smooth surface, and that's why when the light hits it, it doesn't look shiny, it looks dull. On the other hand, if you take a close look at our whiteboard is a smooth surface, and that's why it has a shine to it. Some materials transmit most of the light that hits them. This means the light passes through these materials. However, these materials may cause light to slow down and bend when it passes through them. Refraction, and there's a great picture here of refraction, is the bending of light waves as they pass from one material to another. Materials that can transmit and refract light include glass, water, and clear plastic. Refraction can make objects look as though they are bent or broken. The pencil in the glass of water on the opposite page looks broken because of refraction. Some materials take in or absorb most of the light that hits them. You cannot see light that is absorbed because it is not reflected back to your eyes. When light waves are absorbed, light energy changes into thermal energy. This is why objects heat up when they are placed in the sunlight. Okay, so if you are sitting in the sunlight, you are absorbing the light, and that's why you are going to feel warm. Dark-colored objects absorb more light than light-colored objects. For example, a black shirt absorbs more light than a white shirt. The light absorbed by the black shirt changes into thermal energy. As a result, wearing a black shirt on a sunny day makes you warmer than wearing a white shirt. Okay, another example of this is if you've ever walked around outside in your bare feet in the summertime. A black driveway or a black street is going to feel much hotter to your feet than a light-colored sidewalk. Okay, so having just read this section, Behavior Light, we now know what reflection is, refraction, and also absorbing of light. Okay, and I know many of us have worked on prisms as part of our project. Colors of light. The color of light depends on its wavelength. Red light has the longest wavelength, followed by orange, yellow, green, and blue light. Violet light has the shortest wavelength. Sunlight consists of light of all colors. Light that is made up of all colors is called white light. So, white light has all the colors of the rainbow as part of it. The color of an object depends on the color of light that it reflects. For example, a green object reflects green light. It absorbs most other colors of light. So I always thought this is very cool. If you think about a green apple or a green tree, it's reflecting, it's pushing back the green, and it's taking in all the other colors. When white light passes through a prism, light waves with shorter wavelengths bend more than light waves with longer wavelengths. As a result, a prism separates white light, here's white light coming in, okay, into all the different colors in a rainbow: red, orange, yellow, green, blue, indigo, and violet. Raindrops act like prisms when sunlight passes through them, and this is how a rainbow forms. Okay, so you're now going to go ahead and you're going to be working on, okay, your light energy packet. You're going to notice that I have page numbers here, okay, to help guide where you can find the information. And as Mrs. Hasey and myself have spoken to you about, you should be going back through your packet as you're doing this, okay? The questions pretty much go in order of the packet, and make sure that you're highlighting the key ideas and skimming and scanning. Okay, do your best work.